A DIY solar kit can look cheaper when the first price shows only a panel or battery, but a working AC kit also needs charging control, safe connections, protection, and an inverter. A power station puts many of those jobs inside one box, and many models still accept compatible solar panels. So this is not solar versus no solar. Choose modular control only if you will own the matching, protection, assembly, and testing. Choose integration if you want fewer separate parts. This video compares portable off-grid backup for selected household loads, not rooftop solar or powder. The exact parts depend on whether your loads use DC, USB, or household-style AC. A portable power station normally combines a rechargeable battery, an inverter, charging electronics, and output ports in one enclosure. Solar input is model-specific, so you still have to check the allowed voltage, current, power connectivity, and panel compatibility. Neither path creates free extra capacity just because a panel is connected. Before you compare products, write down only the devices your family actually plans to keep running. That might be phones, a router, and motive. Watts describe power at one moment, while watts multiplied by hours gives a basic watt-hour estimate. Motors and compressors may also need a brief startup surge above their normal running draw. Real runtime can be lower than paper math because of conversion losses, cycling loads, temperature, battery limits, and age. That is why this video will not promise that a battery size runs any appliance for a fixed number of hours. The strongest reason to build a modular kit is control over the individual components. You may be able to choose a different battery size. For your own use case, trade-8 3K3 but that flexibility transfers the matching work to you. The controller must fit the panel input and the battery's charging requirements. The inverter must fit the loads, and every cable, connector, and protection device must fit the current and system design. A shopping cart full of individually good parts is not automatically a compatible system. If you are not prepared to verify those relationships, stop before buying a pile of components. A power station reduces the number of separate boxes you have to select, mount, connect, and troubleshoot. The trade-off is that the battery, inverter, controller, ports, and software are designed as one product. You may have fewer choices for repair, expansion, or replacing one internal component. And the front label is not enough. Check watt hours, continuous AC output, stated surge behavior, recharge options, solar input limits, weight, storage reels, warranty, and recall status. Plug and play still requires planning. It just play price. Invert price of a bare battery with the price of a complete power station. Price, the UI path, all the wear, the rate. Then compare that total with a power station that actually meets the same load and recharge plan. DIY may cost less in one design and more in another. A power station may cost more for integration, but it can reduce setup time and compatibility mistakes. Neither result is universal, and neither option is automatically the better value for every family. Solar charging depends on more than the wattage printed on a panel. Location, season, time of day, clouds, shade, dirt, temperature, panel angle, and the receiving device's input limit. All TA'd are, if your safe panel location is small, shaded, or temporary, build your outage plan around that limit. Leap wave. Wall charging vehicle charging where the manufacturer allows it, and load reduction as separate backup paths. Do not buy a larger panel until you know the controller or power station can accept its voltage, current, and power range. This is a buying comparison, not a wiring guide. Follow the manuals, verify compatible parts, look for relevant third-party safety certification and TRINC. CPSC recalls for the exact model. Stop using equipment, swollen, or quite obeyed. It's Stimiano per cop, Heavy loads, permanent circuits, medical equipment, or whole home backup need a specific system assessment and qualified help. Choose modular DIY only if you value component control and are willing to own the matching, protection, assembly, testing, and maintenance work. Choose an integrated power station if you value portability and fewer separate components, then size it to your real loads and recharge options. In both cases, start with the load list, compare the complete system, and treat solar as a variable recharge options. In both cases, start with the load list, compare the complete system, and tweet solar opposite